Which emerging application areas do you expect to be the main drivers of the next stage of development for FFF?
So I do think that there will be a big venture basically from the research applications to pharmaceutical and real life applications, and that especially biopharma will be one of the strongest drivers here for the future of AF4. Um, because we're also looking at the moment at much more modern and more complex pharmaceutical samples. For example, there's like AAVs where they can be loaded or they can be empty and they need to be analyzed. What was established that it works very well with AF4 in combination and with multi-angle light scattering. We're talking about lipid nanoparticle molecules that have very large size distributions, more delicate samples like extracellular vesicles. And there's just a lot of samples that are hard to control because they're prone to aggregation. But basically that heterogeneity then affects directly like the efficacy and the safety of your sample. And so there, I think that AF4 will enable basically the separation of those populations and can then link the size directly to aggregation states and also structural data in one experiment, what should help with quality control or, for example, formulation efforts for novel therapies. And there's still, there's still a lot of things needed to make it fully implemented in biopharma. I think there's a need for like automated method development and standardization and to make the method more accessible to biopharma. But I do see that FFF here can help answer questions that are very relevant for the field and where FFF can also then support decision making and improving or controlling processes, parameters, and also product quality.
Also, I want to add another field which I think is very important for the future, and this is environmental and also nanoplastics analysis. Yeah, we all know that it's not a question of presence or existence. It's everywhere, nanoplastics, and we now need to find out in which size fractions, or also what's the chemical composition, or also what's the relevance with regard to exposure. And this is not limited also to environmental samples. It can be transferred also, or it's very relevant also for food, beverage, consumer products, how it's been tested actually also for the microplastics. And I think there in this field, AF4, in combination with, of course, a good detection system, like, for example, ICP-MS or pyrolysis, GCMS, Raman spectroscopy, allows a size depend or a size resolved, but also a chemical information delivery. So it's not just averages that we get. And I think this is very important. But we have to be careful because also the sample preparation is essential, especially when you have a complex mixture. And there, of course, we all know measuring standard materials is quite easy. But if it goes to the real world, then we have much more than just one particle in the solution. And this makes it, I could think, quite challenging. Also, low concentrations and interferences need to be considered in that field. Coupling other techniques, like as I mentioned, ICP-MS, but also scattering methods like X-ray or also neutron scattering allows a much deeper insight into the structures. So we can see now structural levels of molecules which were not visible before. And I think in the future, so maybe in 5 or 10 years, also other advanced spectroscopy methods can be coupled to FFF to get a size resolved information about the structure, or maybe microfluidic bioassays could be coupled. But I think, of course, always is in combination with robustness and reproducibility. And this is a big point that has to be considered in coupling advanced detection systems to FFF.